Test, test. Okay. Hi everyone, I'm Mladen Bošnjak, and I'm going to talk a little bit about Godot, which is an open source game engine that's trying to just revolutionize itself and modernize itself to be a competitor to Unity and Unreal with the version 4.0. So how am I qualified to talk about this? Well, I'm not a programmer, but I do everything else on video games. So yeah, I made this game and this one, and the first one is on Steam, the second VR, and the third one from mobile, so I've tried all of this, and these two are Unity, this is Neo Axis engine, that's an old engine that's kind of dead. And right now I'm working on a game in Unity, and I'm trying to get the best graphics that I can. That's always my kind of goal. Of course, to have good gameplay first, but I just love graphics, so that's what I focus on. So why are we talking about Blender now? Well, because I think that Godot is trying to do what Blender did for 3D. So just about everyone uses Blender now, even the big AAA companies, and everybody was using Maya and 3ds Max and programs like that before. And a lot of that, I think, has to do with the main guy that kind of steers the ship, even though they have the foundation and everyone makes decisions together. But I think you need to have like this main face that's kind of the main guy of everything. And Godot has that in this guy, Juan. Yeah, he tweets about Godot all the time. He kind of lives for it. He discusses it, and I think that's kind of good to have. And I think he's kind of the driving force behind the engine. But that's also a little bit of a double-edged sword, and we're going to get back to that in a second. So why is this 4.0 a big deal? What's wrong with current Godot? It has these PBR, physically based rendering materials that we use, which is kind of how you describe a material to be realistic. Like in real life, you have a texture that's how metal a surface is, how smooth it is, and what color it has, and then you get these realistic reflections and everything in all kinds of materials. So you can get stuff like this with just a few textures for your characters, for objects, for the floors and everything in your game. Okay, so that's great. It has post-processing. That's the bloom that you see, and the depth of field, like the blurring behind, and all this stuff. This is like SSAO, which we use to fake small shadows and stuff that you can't reach with global illumination. We have some kind of global illumination in Godot. That's great. So the left picture is something that you would see like in Doom 3 or games from that era. And the right one is like the modern technique where you see the light bouncing off of surfaces. So just like in real life, this box should have some red on it, even though the light's not directly shooting at it. So what's the problem with 3.0? It's based completely on OpenGL, and OpenGL is getting kind of old, and any modern feature that you would expect in a video game from 2013 that you saw on your PlayStation 4 needs to kind of be hacked in and can't be directly supported by Godot. Also, Godot has some basic features missing that video game engines have had since like 2002. We're going to get to that. And then optimizations, you make the same scene in Godot and in Unity, it just won't run as good, even though you optimized everything and all that. And the development started in 2001. Why is that bad? Because the core of the engine was built without having in mind dual core processors, never mind 16 cores ones, even though we can also say that like Unreal Engine is from '96 in that way, but yeah, they also have their problems. In Unity started in 2005. So what's awesome about 4.0? It has a modern renderer, which is Vulkan. That's designed by the same guys behind OpenGL. You probably know more about that than me. But yeah, it's a modern renderer that's used in many modern video games. It's a competitor to DirectX 12 by Microsoft and proprietary APIs that PlayStation has. So it supports volumetric lighting. This is something I wanted to show directly in Godot, but I'll try to just explain it really fast. And then we have these modern global illumination and reflection techniques, decals, which is something that was sorely missing before, and GPU particles. So volumetric lighting. That's basically how in real life, when you have a foggy scene, a foggy setting, the particles in the air the denser they get, the more you can kind of see the air. Like if you have a lamp at night, you can see the rays that the lamp shoots down through because it's hitting all the particles in the fog in the air. You can kind of see that halo of the light. Or like when you see the fog on the floor, sometimes you have fog like in low spaces, and there's no fog in upper spaces. So that's something we simulate with volumetric lighting. Modern global illumination and reflection techniques. Godot uses a pretty cool modern technique where they take the whole scene that you build. It doesn't matter if you have you have an object that has 1 million polygons and you have a room that's like 5 polygons the walls. Godot kind of makes a voxel version of the whole scene where everything is made out of little blocks out of voxels. So it doesn't matter how dense something is. And it just kind of creates this fake scene, which you can use for the reflection because it doesn't have to be perfect most of the time. And you can use it for global illumination because you can shoot those rays of light into this voxel version of the scene. So it's like 1 million times faster, and then you just apply that to your detailed models. Decals are just, you can think about it like stickers. You just have a sticker here that, I don't know, says something, some kind of logo or something. We use that all the time. You make a room and it just looks boring. It has the same walls with the same texture, and then you put like little scrapes on the walls, you put damage and stuff. That's a bunch of textures that you apply like stickers wherever you want. And GPU particles, if you've played something like God of War from 2016 or these modern games, it's when you have like these magic stuff where you have 1 million little things flying, 1 million particles flying around. That's because their position and rotation is calculated on the GPU, which is always faster than doing things on the CPU. So you can have a bunch of particles flying around and interacting with the world. So this is a screenshot I found that's in 4.0 in Godot. And basically you could kind of make this screenshot in 3.5 because the main thing is it supports PBR materials. So as long as you make a really beautiful model, that's the main thing, and beautiful textures. But you couldn't have this volumetric fog. You see how it has like a little haze, or like the light is interacting with the air, and back here the blue stuff. So yeah, that's something you can pull off in Godot now with 4.0. So that was all kind of set dressing visual stuff. That's not really as important. If you need volumetric lighting for a game, if you need this stuff, you can write it yourself or find some solution on GitHub and put it into Godot 3.5. What's really important is that they're modernizing the core. So I said it's from 2001. And they're taking this opportunity to break compatibility completely between 4.0 and 3.5 and just rewrite all this legacy stuff to work on modern CPUs, to work on modern GPUs, to just get all the power out. So they're rewriting all the legacy code. This is really important, asset importing. So I'm not a programmer. So what's important for me when I turn on an engine, I'll try and take my Blender file and I'll try and drag it into the engine to see what happens. And what I want to happen is to see that model in the engine and then be able to drag it in my scene. And that's not something you could do. That's something that Unity is the best at. You can just drag your stuff. Even a kid could do it. You know, it's the fastest way to do stuff. And that's what they're trying to kind of achieve. And it has these optimizations that it was missing. LODs, that's the system where, okay, you have a model that's 1 million polygons. And that's when it's really close to you. You want this guy to look beautiful when he's in front of the camera, let's say, a character. But when he's 100 feet away, you don't want to render all those polygons. So you swap him for a simpler model that's less polygons. You won't have enough pixels because he's far away to actually see the difference. So you just swap this guy the farther he is for simpler models. And the occlusion culling, that's when the GPU just draws whatever it sees, back to forth. So the furthest thing the GPU sees, that's what it draws, and then closer and closer. It doesn't know if there's a giant wall in front of you, and that it doesn't need to render all the trees and everything behind the wall. And with this occlusion culling, we kind of bake a simplified version of the scene again, and then the GPU knows, okay, the player is looking at a wall, it's obstructing everything behind, and then you can just save a bunch of render time because you're not rendering everything that you don't need. Okay, so what's missing in 4.0? There's a lack of motion vectors. And motion vectors are when something is moving in the scene, it kind of leaves like a trail, a line where it was going for the GPU, so it knows how far it moved and what velocity it has. And that's what you can use to get this beautiful anti-aliasing. I don't know if you can see, but anti-aliasing is getting rid of all these jaggies. So the GPU renders objects with edges, and depending on your resolution of your screen, you get these jaggies. And then we kind of try to smooth this out. And FXAA is an old technique that Godot uses, and TAA or temporal anti-aliasing is what everyone uses now on PlayStation 4, 5, and everything else. So yeah, motion vectors are not planned for 4.0, which is really a bummer, but that's how it is. And here's that double-edged sword. So here's the guy leading development. He says he is dead set on not using temporal anti-aliasing because it will make users, it will make it harder for them to write their own graphics code. So then in this Twitter thread, he starts, backing out of this, what he said, and everybody's kind of shitting on him. So yeah, that's kind of a problem when this guy says he's dead set on something and he's the leader of it all. And this doesn't make much sense. Like, users can write their own graphics. What I want is to have beautiful graphics in the engine already, and if I have a really good programmer that wants to write his own graphics stuff, he's probably gonna know, even if it's a bit harder, I guess he's gonna want to have motion vectors and all this to get beautiful graphics. So yeah, all the rage now is these upscaling techniques in 3D graphics, which is where you render a scene like at a fraction of the resolution that you actually show in the end to the player, and you kind of jitter the screen to get as much data as you can, and that through a few frames of rendering, you blend that together, you get a bunch of information from it, from these motion vectors, and you get the same image as you would if you rendered all the pixels. And that's NVIDIA DLSS, probably heard about that, and AMD is now trying this stuff with their own FSR 2.0, and temporal upscaling. And for the engine to know if something stayed in place between 5 frames or if it moved, and when where it's going to move in the next frame, it needs these motion vectors to know how to do this stuff. So that's what we're missing. We also can't have per object motion blur because we don't know how things are moving. So you can't get this cinematic quality in each frame like you would see in a movie. If you stop a movie, you can see the blur from like fast movement. You can't get that in Godot. Every frame is going to be totally sharp, pristine. Oh yeah, so this is a big one. You can't use multiple displays in Godot. So this is literally just me print screening my screen while I was working on this presentation. And you can see that if you're working on some serious project for a client or something, you're gonna need 2 screens, maybe more, depending on how you work. And yeah, you're gonna have to wait for these things. That's why it's called Godot, because you're always waiting on it. We'll see when 4.1 is gonna come out. We'll see when 4.0 comes out, because it's in alpha now, so who knows. Also, ray tracing. That may seem like modern or like a buzzword everybody's using now, but actually for us that have been in graphics really long, that's like the holy grail that we're trying to achieve. We fake a bunch of this stuff with screen space information that the GPU sees, so you kind of get really good graphics in a screenshot, but when you start moving around the scene, everything starts breaking up. And the only way to solve that is with ray tracing. And NVIDIA started with RTX, and now AMD is going on with ray tracing, like dedicated hardware in their GPUs. And PlayStation 5 and Xbox One, Xbox Series S, I don't know what they're called. They all have dedicated hardware for this stuff, so why not use it to speed up that global illumination that we have every time we need to shoot some rays around? We can do that with this hardware. Vulkan supports it, so that's great that Godot is switching to Vulkan, so at some point, they'll be supporting it. I mean, you can always theoretically write it yourself, make a plugin, since it's completely open source, Godot, but yeah, that would be hard. So this is a real bummer for using Godot. You'll never be able to build 2 consoles natively from the engine, because if you want to build to Switch or any of these consoles, you need to use their SDK, and those are closed source, and that's against Godot's politics. So they can't officially support a closed SDK because it needs to be completely open source. So if you're gonna use Godot and want to build the consoles, you'll either need to use a company that does that. There's some guy that ports to Switch, has a few successful projects, and I've never seen a Godot game on PlayStation or Xbox, so that's kind of a bummer. Let's compare it with Unity. So yeah, Kolega Voras said that Unity has a lot of bugs. I think Godot has even more. Even though they're calling this Godot 4.0 an alpha, it's it's still kind of stable as like an official Unity version that they say is stable. So maybe they're getting there. Maybe it's going to be more stable. But yeah, Unity likes to break stuff between every iteration of the engine. And if you're working in VR, AR stuff and all this like emerging technologies, every version is going to have some kind of gimmick that you have to solve when you're working with it. Of course, Godot is completely open source and free. Unity is free, except if your company is making $200,000 a year. Not with Unity, like just if you're making that kind of money, then you need to buy the licenses. And if you want the source code, I think it's $1,800 per user per year. So yeah, I think Godot is better on that point. Also, Godot is 50 megabytes. Unity is like 3 gigs or maybe more, depending on how you're using it. What about Unreal? So everybody's talking about Unreal Engine 5 and these Lumen and Nanite technologies. And that's awesome. That Nanite technology, I don't know if you've seen it, where you can have 1 billion polygons on every object, and the engine handles how many it's going to render based on how close the object is to you. And it clusters the whole scene into this giant array, and it's really good in theory. In practice, there's no games on Unreal Engine 5. And it kind of sucks. It needs a PC with 64 gigs of RAM and 16 threads CPUs at least, and it like barely works. I've been trying Unreal Engine 5 for a while. Every time they do a patch or a new release, and I don't know, man. It's really for AAA companies that have a lot of resources, and also it's 150 gigabytes, I think, just Unreal Engine 5 download, and Godot is 50 megabytes, so that's kind of a difference that like a novice user would probably go to Godot to try stuff out. What about Lumen? Unreal is really pushing this Lumen stuff where they say, okay, just put anything in your scene, you're going to have beautiful lighting, you're going to have beautiful reflections. Well, actually, that's not that magical. It's really close to what Godot is doing with that voxel-based global illumination, where you use the voxel representation of the scene for the reflection and for the global illumination. It's really, really similar to Unreal's Lumen, so they're not actually doing anything revolutionary there. They just kind of market it really, really well. So yeah, that's basically between Godot and Unreal. Unreal is also completely free to use. Except if your company makes like $1 million from your game in Unreal, unlike Unity, where the company just makes that money. So if your game makes more than $1 million, you have to give 8% to Unreal Engine from that point on. So that's really generous and nice, and I think Unreal, if you're making a AAA game, kinda is the best way to go. So yeah, this is the Lumen that I was talking about, where you have the real nice global illumination, and here you have the nice reflections. And we could actually replicate this really faithfully in Godot, and I wanted to show that, but unfortunately, that's not going to happen. And this is the Nanite, where they're clustering the whole scene into these little blocks, and they're rendering just what's needed, so you can have bajillions of polygons on the screen. But again, it just doesn't run well. They have that Matrix demo that you can download on PlayStation 5 or on your PC, and the most you can get is like 26 FPS, I think, on a PlayStation 5. So that's not really promising. I don't know how they're gonna optimize that, because people want to play video games at 60 FPS these days, and we're getting 25 from Unreal Engine 5, but I hope they can fix that. So, would I recommend Godot? If you want to make a game with awesome graphics, and here I put a screenshot of my own game, which is kind of lame, but that's what it is. So basically, I think that if you look at this scene, this is volumetric lighting. This is a bunch of GPU particles, the rain. These reflections are the same as in Godot. Actually, in Godot, they will be a bit better and run a bit faster. So a scene like this, you could replicate. This is in Unity, by the way. You could replicate fairly easily if you use the same assets in Godot. So yeah, if you want to make a game with graphics like this, sure, when 4.0 reaches a stable release. If you want to then release it on PlayStation and Xbox, then don't use Godot, unfortunately. But yeah, if you're starting out and you want a small engine that you want to try stuff in, I think Godot is really, really good for that. And I put a hammer here just to illustrate that the engine is kind of a tool, and a scene like this would look identical in Unreal and Unity and Godot. It's kind of up to the artist to make it look beautiful and optimize it. there's not some special thing that Unreal can do here to make it look better. It all depends on your art. So that's why it's important for Godot to have all these kind of basics of what video games today use, like global illumination and volumetric lighting. So you can get kind of the same scene in all these engines. So you can compare them and kind of have them fight. So bonus round. While I was searching for all this stuff about Godot, I saw that there's a new engine coming up. That's a Linux Foundation project, so you probably know what that means better than I do. And it has an Apache 2.0 license, which I guess is open source. It started a year ago, and it looked really promising to me. It promises AAA quality, and it's backed by the Linux Foundation, so maybe something's going to come out of that. And this is the only screenshot that they have on their website. But then as I started digging, I saw that it's built on Amazon Lumberyard, which is built itself on CryEngine from Crytek, which you may know from Crysis and Far Cry. And that game that you saw, I went on their Steam page and they switched to Unity already, so that's not a good thing for these guys. But maybe it just needs to mature, and they're really like Godot is pushing for ease of use, to be 50 megabytes. To if you're just starting off in game development, to kind of be able to use it. If you want to make a mobile game, a 2D mobile game really fast, Godot is perfect for that. And even if you want to make beautiful graphics, it can work there. These guys are really pushing for AAA stuff. So yeah, the last thing I wanted to say about Godot is that it works on Android. And yes, it actually works on Android. I can show you later. You can just turn it on your phone. It doesn't support the touch movement or whatever really good, but if you just plug in a keyboard and a mouse, you can actually kind of go around your scene, build stuff. And that's fascinating. I think that's great for one main reason. And first I want to preface this with a little story that I have. So when I was finishing college or university, and I had the final assignment, I had a professor there that, first I had a kind of VR thing because I wanted to wow them with VR. That was 2016 when it was all starting. And I did a VR thing in Unity, and I showed them that. And after that, I had this old professor that was on the board giving me the grade. He started some rant about how Photoshop and all this stuff should remain pricey so that you could only use it at college, and that kids don't use it so that not a lot of like bad designs come out and on the internet. And he just struck a really like bad chord in me. So I said, well, everything I showed you in VR, you've taught me none of this in school. Everything I've learned is from either free software or pirated software. So yeah, I totally don't agree with you. Luckily, he already gave me the grade. So yeah, this is something that I think is really important, that this works on Android, because you have like billions of smartphones, more than people in the world, and you have all these little kids in Africa and in India. They all have a smartphone because they got it from somewhere. They're cheap. They don't have a PC with 64 gigs of RAM and a bunch of cores on the CPU. But they can download Godot on their phone, and if they find like a mouse and a keyboard somewhere, they can start to make video games, you know. And I think that's really important, to empower all these kids that potentially wouldn't know what a game engine is, to kind of empower them and make them be able to show what they can do, and then get out of the life they have and start making video games and improve that way. So that's about it, I think, for my presentation about Godot 4. This is my email if you want to hit me up about this stuff. And that's about it, I think. So thanks.